Hello friends, today we start new chapter and that is moving charges and magnetism. All age people are always attracted toward the magnet, and if you see the history, then there is some story about the magnet which was found in area Magnesia in Turkey, and on the basis of that area this matter is called magnetite, and now we say it is magnet, but that is for permanent magnet. What is the origin of magnetism? That we will discuss in this chapter. Who has started this work? How we can calculate the magnetic field? How magnetic field applies force on a magnet? And with the principle of magnetism, how galvanometer works, how we measure the voltage, how we measure electric current, then the cyclotron. And in second part of this, we discuss permanent magnets. Looking to the importance of this chapter, if you see NEET paper, then in NEET, weightage is around 6%. In J also is good weightage, 6 to 7%. So we expect minimum one question, maybe two questions from this chapter. There is very good physics involved in this concept. If your concepts are very clear, then you will enjoy to solve the problems. I am confident that you will be able to solve the problem yourself if you do practice with understanding. So if you see your textbook, so at the beginning, Lorentz force is discussed, and origin of magnetism we discuss in 4.5. I start with the origin of magnetism and then we discuss Lorentz force. You already studied in electrostatic, so whenever you have charge Q, so at the vicinity nearby there is an electric field. Depending on the charge there is a direction. And if you put any charge on that, then because of this electric field, force is exerted on the charge which is placed here, and you can calculate what is the force. F is equal to QE. E can be calculated in two ways. One is Coulomb's law and second one Gauss law. Coulomb's law, you know that it is inverse square law. Whatever the charge distribution, you can apply Coulomb's law and can be calculated what electric field at a given point. And if charge is distributed symmetrically, then we can apply Gauss law to calculate electric field, and that method is little bit easier but is true only for symmetric system. Similarly, when charge comes in the motion, surrounding to that we have magnetic field B, and B can be calculated again with two methods. One is Biot-Savart law, and second one is Ampere's law. So this can be applied at any place, but Ampere's law cannot be used in irregular shape, and it is true. It can be applied only for those systems having symmetric configuration. We start with this Biot-Savart law. Before that, I want to discuss about the Oersted observation. About the Oersted's observation. Oersted observation. So it is around 200 years back. The story started with Oersted observation. Before this, it was believed that magnetism and electrostatics are the separate branches. But after the observation of Oersted, it is found that magnetism and electrostatics are two sides of the coin. And then many scientists work on that. Among them, the famous Maxwell's equations are derived on the basis of this theory. What is Oersted observation? What is observed by the Oersted? You must be studied in 10th also, but just I summarize. Suppose you have a conductor and it is connected with the battery with the switch is in series, and a magnetic compass is placed nearby to the conductor. If there is no current, then needle is settled parallel to this. But as you pass the current by switching on, this needle shows the deflection. So Oersted concluded that this deflection is due to the current passing through the conductor. If it is reverse direction, instead of plus here, this is negative and this is the positive, then current direction is opposite. So again, this magnetic compass gives the deflection, but it is in opposite direction. Suppose in first case it is in upward direction, so while reversing the current it is in downward direction. This is the observation made by the Oersted. Then what is the magnetic field? It is not calculated, and it is done by two scientists, One is called Bio and another one is called Savart. They derive one law, it is called Biot-Savart law. Biot-Savart law, and it is very well known. They have performed series of the experiments, such type of measure the magnetic field with the direction, and finally they made one conclusion. What is that? So this is one current carrying conductor which carries current I, and this is the place where we want to find out what is the magnetic field. So this is irregular shape, so it is divided into small current elements. This is one current element, the second, there are so many, but I show here one current element here. So this is called IDL, length of the element is DL, IDL is called current element. Current element, and it is in the direction of the current flow, directed in current flow. Again I remind you that this is conventional current, it is opposite to the direction of the electrons. So opposite to electron flow. It is a vector quantity. You cannot separate these two things, I and dl, both are separate. No, it is a common thing, IDL. And unit is ampere into meter is the unit. Then I take one position vector with respect to this. So this is the position vector R. So R is the position vector of P with respect to considered current element. Then how P is defined? So if magnetic field at P, I take this small part, so it is P due to current element. Is dB, it is a vector quantity, so I use the vector. dB is given by mu 0 upon 4 pi IDL cross R upon R square. This is no proof, without proof. So it is observed that this magnetic field is proportional to the current. It is proportional to the current length of the current element and inversely proportional to the square of the distance, as well as it depends on the position. P may be here, P may be here also with same distance. Same distance but position vector is changed and therefore this theta is also get changed. So it also depends on theta. And how it is changed? With the sine theta. So cross product is used. As we know that it is a product of two vectors. So this you can write like this also, mu 0 upon 4 pi I dl. This is unit vector because magnitude of r is 1, and this is say a, this is b. So a b sine theta. So I take sine theta because we know that the magnitude of unit vector is 1. Not necessary to mention, it is very well understood. And divide by r square. Sometimes if you see here vector r is used, because r is equal to vector upon magnitude of the r. So sometimes you find that this vector r upon r cube. R cube doesn't mean that it is a cube law. No, it is a inverse square law. It is a inverse square law, which is similar to the Coulomb's law. It is a inverse square law, similar to the Coulomb's law. In Coulomb's law also you know that k q1 q2 upon r square. There Coulomb's law is a little bit simpler because just it is a product of two scalars q1 and q2, here product of two vectors. So little bit is difficult to handle Biot-Savart law compared to the Coulomb's law, but it's not that much difficult, it is very easy. So this is dB because of that small kernel. But if we are interested to find out the magnetic field of whole conductor, so what is my B? So it is nothing but integration of dB for whole conductor L, and this you can write as mu 0 upon 4 pi is constant in this. You can take I also outside, but I don't want to take it outside. I dl cross r upon r square for whole conductor. One thing we are still not defined, what is mu 0. So mu 0 is called permeability of free space, or you can say vacuum, no problem, free space, and its value is 4 pi into 10 raised to minus 7 with SI unit. So what is the SI unit? So here I write what is the unit of this. So this magnetic field is in Tesla, so I write in left side Tesla. Magnetic field, unit of magnetic field is Tesla in SI system, is equivalent to current is ampere, yes, this is in meter, yes, this is unit vector unitless, divided by meter square into unit of mu 0. So unit of mu 0 you can find Tesla meters, the one is cancelled out. So unit is, you can write that, you can see that Tesla meter per ampere. Unit of B is Tesla in SI system international. And if you see it, then we use Gauss. So 1 Tesla is equal to 10 raised to 4 Gauss. Sometimes you will see this unit also. Tesla is equal to 10 raised to 4 Gauss. So remember this relation also. So this is the permeability of free space. So whenever we discuss magnetism, this will appear, and whenever we discuss electric field, epsilon 0, that is the permittivity of free space, will appear. Mu 0 is the permeability and epsilon 0 is the permittivity. This is one property of a given material. So later on also we'll discuss this permeability and susceptibility of magnetic materials. Okay. Now this is the magnetic field. You can find the magnitude as a direction. So how you can determine the direction that we discuss now. So this is ideal, okay, and this is your R. So in the formula you can see that magnetic field is in the direction of ideal cross R. So this is the ideal, this is ideal, okay, and this is your R. Just I want to explain it. These both are in the same plane. These both are in the same plane. So where is your B? So B is perpendicular to this plane. Perpendicular to this plane. And we know that when we have vector product, resultant direction can be determined with right hand thumb rule, you can say, or right hand screw rule. So you put thumb in this direction and finger I put in this direction. This is my right hand. So when you draw the normal to the palm, it goes inward. So to show inward we use cross. So direction of P is inward at point P. You can use screw rule also. So you have to rotate your screw in this direction. Sorry. You have to rotate your screw from first vector to the second vector. So first vector is up, second vector is right side. So when you rotate your screw like this, screw will go inside. When you rotate your screw like this, screw is going inside. So this is the direction of B. This is the direction of B. You can use whatever you like. If point have been selected other side, this side. So this is your first vector. I take this first vector here, ideal, parallel to this one, and B in this direction. Okay. Here R in this direction, R in this direction, ideal in this direction. So I have to rotate screw like this, means anti-clockwise. So if you rotate your screw anti-clockwise, then it comes out. So if you took this point, the direction is outward. If you take this point, direction inward. So this is the way you can find the direction of magnetic field. One thing is sure, it cannot be in the plane. Second thing, if you want to find out magnetic field along this line, so R is here, ideal is this, means angle is 0. So if angle is 0, then this is 0. So you will not find magnetic field along this line. Remember, magnetic field along this ideal is 0. Because of this, because of this ideal. Of course, because of that, you will get the magnetic field. But because of this part, dB is 0, not B. Remember, dB is 0 because of this, not B. Because B is due to all part of the conductor. There is similarity between Coulomb's law and Biot-Savart law. Also, there is a difference. Is something I already told you. In Coulomb's law, electric field is due to the charge, and which is scalar quantity. Remember, electric field is due to charge, which is scalar quantity, means origin of electric field is scalar, and origin of magnetic field is a vector, because ideal is a vector. Both are inverse square law. Here also square is there. In Coulomb's law also square is there. Both depends on the medium. One is electrical property and the second will be magnetic property. Because here mu 0 appeared, in that it was epsilon 0. So there are some similarities and some are the differences. One more thing I want to point out is that we know that mu 0 is equal to 4 pi into 10 raised to minus 7 SI unit, Tesla meter per ampere, and epsilon naught is equal to epsilon not equal to otherwise I get a 4 pi epsilon 0. Okay. 4 pi epsilon 0 is 9 into 10 raised to 9. 9 into 10 raised to 9. Now what we do? I multiply mu 0 into epsilon 0. So mu 0 is 4 pi into 10 raised to minus 7. And epsilon naught is, this is in SI unit of course, and epsilon naught is 9 into 10 raised to 9 divided by 4 pi. Sorry, this is 1 upon, yes. So this is 1 upon 4 pi into 9 into 10 raised to 9. 1 upon 4 pi epsilon 0 is this one. So 4 pi epsilon 0 this one. Okay. So this will cancel out. This minus is going down. So it becomes 1 upon 9 into 10 raised to 9 plus 6, 7, 6, 1. So this is nothing but square of 3 and it is square of 8 also. So this is nothing 1 upon c square. It is velocity of light. So you can say that c is equal to 1 upon root of mu naught epsilon naught. So this is side product of our equation. C is equal to 1 upon root mu 0 into epsilon 0. So smartly one can ask what is the unit of mu 0 epsilon 0. Smartly. So you know the relation. So you can find 1 upon c square means second square upon meter square. What is the unit of mu 0 epsilon? You take the both the sides square. You get c square meter per second whole square. So you can find unit of mu 0 epsilon 0. So that tricky question can be asked. So this is for Biot-Savart law. Remember again, how to find the direction is very important role to find the direction. Right side is going inward. One more way also you can find the direction, but don't be confused. You first pick up one method only. Then if you understood very well, then you can apply any method, you will get same answer. So second way is you hold this conductor in right hand. You have to hold this conductor. You can imagine you hold in such a way that thumb in this direction. I put it in other way. I put it. So this is my conductor. So this is a direction. So I have to hold this conductor putting thumb in this direction. Okay. So when you want to hold, you have to turn your fingers. Turn your fingers like this. Then and then it's possible. So fingers are turning like this. Fingers are turning like this. So actually this is the direction of magnetism. So right side it goes inside and left side it comes out. Right side is goes inside, left side is come out. It is in circular shape. Okay, so you can use any method. Now when we use cross and when we use dot, I just give simplification. Suppose you have an arrow. This is the arrow. Okay. So arrow is going this side. So when you see from back side, it shows cross. So what is if it is going inside? This is cross. And a person looking arrow this side, it shows only he can see only point dot here. So it is dot. So this is outward, and this is inward. Just to remember it. Don't be confused. Dot means outward, cross means inward. Okay, so there are different techniques to find the direction of magnetic field. I take 2-3 examples. Suppose current is flowing east to west direction. East to west direction. So first I take one conductor. Okay, this is I try to explain. This is east side. This is west side. This is north side, and this is south side. We all know. This is the plane, and this is the current direction. So this is the conductor, and current is flowing this direction. Now suppose ask, what is the direction of the magnetic field a point toward the north? અહીંયા કેટલું કઈ directionમાં હશે? So what is to be done? You put your thumb, right hand thumb. You imagine in west side. So I use thumb like this. Okay. So this is my right hand thumb. So my finger goes this side. Yes. My finger goes this side. So my finger is moving like this. So at north side it is going downward. At north side it is going downward. So direction of magnetic field toward the north is downward, but toward the south point it is upward. Can you imagine now? You hold this conductor with right hand. You have to use your pen. Pick up the pen and point toward the west side. Okay. કર્યું? જાતે કરશો ત્યારે સમજવાનું છે. હવે તમે જુઓ મુઠ્ઠી વાળો પેનથી મુઠ્ઠી વાળો જમણા હાથે એ ડાબો હાથ છે, જો જમણો હાથ. તો પેનની સામેની બાજુ, મારી બાજુ નહીં, આપણી બાજુ નહીં, પણ સામેની સાઈડમાં ફિંગર ક્યાં જાય છે જુઓ તો નીચે ગયા, તો ત્યાં કરો ફિલ્ડ ડાયરેક્શન કે છે ડાઉન. તો ત્યાં ડાઉન હોય તો આપણી તરફ ક્યાં હોય? એટલે કે આપણે સાઉથ તરફ છે માની લઈએ. સામેની સાઈડ છે નોર્થ સાઈડ છે, લેફ્ટ સાઈડમાં મારો વેસ્ટ છે, રાઈટ સાઈડમાં ઈસ્ટ છે. તમારે ખુદ you have to do practice yourself, and this is only way to understand. So going down, yes. If I take point toward the sky, અહીંયા point લીધું હોત toward the sky, તો શું થાત? It is going will move toward the north. And if you take point below, then toward the west, sorry, south. This is south direction, this is north direction, this is down direction, and this is up direction. So it will direction like this. So this is the conductor and this is the direction. So you have to think. There is no other way. You have to find the direction. मतलब નાના હતા તો યાદ રાખે છે ડાબો હાથ કોને કહેવાય, જમણો હાથ કોને કહેવાય. તો એ તમારે યાદ રાખવાનું છે. મમ્મી એક વાર સમજાવે કે જે બાજુથી જમે એ જમણો હાથ. કોઈ ડાબોડી બી હોઈ શકે પણ. હા, તો એ રીતે આપણે યાદ જે રીતે રાખેલું તો ડાબો જમણો જે યાદ રાખવાનું જ હોય. તો એ રીતે સમજી લેશો, યાદ રહી જશે. હું થોડું આજે ટ્રાય કરું છું. So this side is north, this side is south, this side is east, and this side is west. અહીં તમે સમજવા આવ્યું હોય તો નોર્થ સાઈડ નું પોઈન્ટ નીચે જાય છે, સાઉથ નું ઉપર જાય છે, ઉપરનું પોઈન્ટ નોર્થ બાજુ જાય છે, નીચેનું પોઈન્ટ સાઉથ બાજુ જાય. So in this way you can find the direction. Understood? Yes, I try to understand. And this is in the explain.